Welcome to Cleantech Conversations, an online event series by the National Cleantech Conference and Exhibition. My name is Tiffany Bauer and I am the Program Director for the National Cleantech Conference. And as we wait for everyone to jump online, we'll just give everyone a little bit of time there as those numbers go up. So hello to everyone from around the country, a very warm welcome to you all. We are hosting this event from Brisbane, Australia today, which is also the home of the NCTCE team headquarters. Before we begin, and on behalf of myself and the panellists, I'd like to pause to reflect on the fact that we are proudly on the custodial land of the oldest living civilization in the world. We pay our respects to both the Jagera people and the Turrbal people and their elders past, present and emerging. Before we commence, we'd just like to announce the launch of the virtual Cleantech Conference and Exhibition 2020. With the challenges and uncertainty that COVID-19 has thrown us this year, we have made the decision to move to the 2020 live event to the end of 2021. However, the response from our recent audience survey, and we thank you to everyone who responded, indicated a clear demand for an event to take place in this calendar year because there's so much to talk about. So the virtual Cleantech Conference and Exhibition 2020 will run from 24 to 26 November. So what can you expect from VCTCE 2020? Well, this will be much, much more than a Zoom meeting, let me assure you of that. VCTCE will be fully interactive and will take place on a tailored online event platform called On Air. Networking will remain a focus of the event, and we will have a number of online tools for our delegates, speakers and exhibitors to connect and engage. So just a few key features. This will be comprising of a 3 half-day interactive live stream, including keynotes, panel discussions and breakout sessions. On-demand access to all digital content will also be available up until the 30th of June 2021. We'd also like to note that there will be a 60% reduction on the ticket price from our live event, so it's very much accessible for everybody. We will send through further details in our follow-up communication, and we invite you to check out our website as we update speakers over the coming weeks. Now, onto our panel session, which I have to say this hydrogen session has been extremely popular and we've had a sold out event today. So today we are discussing Hydrogen Unpacked, learnings on the adoption of hydrogen in Australia and globally, and this is supported by Advance Queensland. I'd like to introduce our panel facilitator, Paul Hodgson, who is the GM for Innovation and Stakeholder Engagement at NERA. Paul is works for the, as I've mentioned, the National Energy Resources Australia Industry Growth Centre. He works with stakeholders to maintain and grow Australia's position as a global energy powerhouse, a sought after destination for investment and the leading source of knowledge and solutions. He has spent much of his career exploring the competitiveness of business, industries and regions and designing and implementing strategies to improve performance through innovation, sustainability and collaboration. So Paul, I'd like to hand over to you to introduce our panel.
Fantastic. Tiffany, thanks very much, and thanks for the opportunity. What a privilege to be facilitating such an expert panel today, and as you say, with a packed audience online. So we're in for a treat in the growing hydrogen economy. There are very few projects that have developed as far as the Sir Samuel Griffith Centre, and shortly Professor Evan Gray will take us through that. But before I do that, I'll introduce the panelists. They are, as I said, a very great expert panel here. We've got Andrew Broadbent, who's Director Hydrogen Industry Development for the Department of State Development, Tourism and Innovation in Queensland. Andrew's worked for more than a decade in the state development portfolio within the Queensland Government across a range of policy roles and priority sectors in that time, including aquaculture, industrial biotechnology and the resources sector. Since mid-2018, he's been coordinating the development and delivery of the 2019 to 2024 Queensland Hydrogen Industry Strategy. Prior to joining the Queensland Government, he worked on the environmental management and EIA processes for a diverse range of activities, including aquaculture, integrated resort developments and intensive animal industries. Andrew has a PhD in tropical marine and environmental chemistry from James Cook University. Secondly, we've got Professor Peter Ashworth, who's Director of the Andrew N. Liveris Academy for Innovation and Leadership and Chair in Sustainable Energy Futures at UAQ. Professor Ashworth, OAM, is the Director of the Centre, as I mentioned, and also brings over 30 years experience working in a range of senior management, consulting and research roles. In her previous role as Group Leader at CSIRO's Division of Earth Science and Resource Engineering, Peter conceptualised and led the Science into Society Group, which specialises in interdisciplinary research at the interface between science and society. Professor Ashworth is a globally recognised expert in the fields of energy, communications, stakeholder engagement, and technology assessment. For almost 2 decades, Peter's been researching public attitudes towards climate and energy technologies, including wind, carbon capture and storage, solar photovoltaics, storage and geothermal. She's actively involved in building energy literacy more broadly within Australia and globally, and regularly provides input to policy briefings, think tanks, as well as educational events for the benefit of the broader community. Emma Brand joins us on the panel. Welcome, Emma, Project Manager, Hydrogen for Origin Energy. Emma is part of the Expanding Future Fuels team at Origin Energy, focused on reimagining fuels and building a greener future for Origin's customers, community and planet. She's spent almost 20 years as an exploration geophysicist and as a project and program manager in the resource industry, both Australia and internationally. She's currently studying for an executive MBA in complex program leadership and is passionate about activating diverse teams to solve our complex problems. Emma is excited about the possibilities presented by Australia's emerging hydrogen industry and believes we'll need different ways of thinking to unlock this unique opportunity. So I really look forward to hearing from the panelists after we've heard from Professor Evan Gray, and I'll introduce Professor Gray now, from the Queensland Micro and Nanotechnology Centre. Evan Gray is a Professor of Physics at Griffith University. His research in solid-state physics includes fundamental aspects of the interaction of hydrogen with materials, hydrogen storage materials, and hydrogen embrittlement of high-strength alloys. The experimental tools used include neutron and synchrotron X-ray beam techniques and the National Hydrogen Materials Reference Facility, which he manages at Griffith University. His applied research encompasses hydrogen microgrids, hydrogen storage for off-grid electricity supply, metal hydride compressors, and computer modelling of all aspects of renewable energy systems from the device to the enterprise level. He's closely associated with the Sir Samuel Griffith Centre, a solar-powered building which demonstrates hydrogen energy technology. Evan is also Deputy Leader of the Offshore Renewable Energy Systems Research Program in the Blue Economy Cooperative Research Centre. So welcome, Evan. Really look forward to hearing your presentation. If you'd like to share your screen, and then we'll move to a discussion and Q&A session after your presentation. And for the audience, please keep the questions coming in the Q&A section. Thank you, Evan.
Okay, great. Thank you. Good afternoon, everybody. Hopefully you can all hear me and see the presentation okay. If so, you may hear about the Sir Samuel Griffith Centre and see it on the web. This is it. It's a building. It's a building covered in photovoltaics. The bit we're interested in today is down here. It's the hydrogen microgrid, which you can see here housed in a building associated with the main building, designed at the same time. So it's not an add-on. And this is me looking pleased with myself because a Mirai is a nice car to drive. So first of all, let me say a few words about hydrogen. I'm also going to take the safety bull by the horns very swiftly, because most people know at least one thing about hydrogen. If they don't know anything else, they've heard of the Hindenburg disaster. So I want to tell you some facts to help displace some of the myths from your memory, I hope. One thing to note about hydrogen is that the flame, when it burns, is colorless. That's actually dangerous, but it's a key to understanding the Hindenburg disaster, in fact. Another thing about hydrogen is it has fantastic energy density by mass. It's a wonderful fuel. The problem is that if you measure the energy density by volume under ordinary conditions, 1 atmosphere room temperature, it's terrible. And that's because hydrogen is a gas at room temperature with very low density. It doesn't liquefy until cryogenic temperatures. This is minus 253 degrees centigrade. So that's the nub of the problem of storing and distributing hydrogen. How do you get it in a sufficiently condensed form? Another thing to note about hydrogen, and the number might not mean anything, but this diffusivity is quite a high number. Hydrogen, if it escapes, diffuses very quickly. In other words, it's gone. So it doesn't linger, it doesn't form burning pools. It has a wide explosion range, but you have to have quite a big leak to get this much in a closed space. And if you have pure hydrogen, then there isn't any risk of explosion. So to the safety aspects. This is an explosion of something most of us have around our homes in the form of a barbecue tank, fuel tank, or in many cars. Some of us run our gas cookers. LPG is really, really dangerous stuff. This is the Hindenburg disaster that everybody knows about, and this is the initiation of the fire. There was no explosion. This is the skin of the airship burning because it was covered in a very, very flammable material. This paper in the International Journal of Hydrogen Energy has quite a bit of detail about this, and I don't think there's any doubt anymore about what happened. And in that same paper, you can actually see a picture of a helium airship burning. Now, helium is the least flammable gas you will find on the planet, pretty much. It just does not burn. So the problem was the flammable skin of the airship. Another fuel we all deal with almost every day is petrol. So this is the record at the same time of fires ignited in the fuel tank of a petrol-driven vehicle and a hydrogen vehicle. This is after about 1 minute, I think, same time in each case, and it's pretty obvious which vehicle you would survive in. So to move on to the topic itself, this is a list of opportunities that you could come up with in a few minutes, and I'm not going to go through any of them in any detail at all, but merely point out that these are opportunities over a range of scales for what I call a hydrogen microgrid. That is an electricity microgrid that has a second energy vector or carrier in the form of hydrogen, in a sense running in parallel with the electricity microgrid, so they interact. So the components of a hydrogen microgrid are an electricity microgrid and some hydrogen equipment. Many, many opportunities across the remoter regions of Australia, at high scale opportunities related to export. And these ones down here are just some of my favorites, projects that I would like to be involved in myself, am involved in. The Sir Samuel Griffith Centre was the foundation of involvement in some quite important projects in the scheme of things, still small scale because the industry is incipient. But it led to my involvement in a couple of projects that are doing, we think, some quite important things. The first one is this ARENA project, which is related to export, but it's about hydrogen microgrids. And if you like, the complexities of having all of these components on a microgrid, having them all sing and dance together. This project's led by my friend and colleague Ian McKinnon from QUT, and at Griffith we're mostly responsible for the modelling aspects of the project. So this came out of the building of the Sir Samuel Griffith Centre hydrogen microgrid and the experience we gained in operating that, making it work and making models for it. The other one I'll mention is the Blue Economy Cooperative Research Centre, where we do now have board permission to begin the design and construction of a hydrogen microgrid. Phase 1 will be onshore, but eventually we will be taking it offshore, and it will be situated in association with an offshore aquaculture installation. The scale of this is going to be sub-megawatt, hundreds of kilowatts to nearly a megawatt in scale. So yeah, another quite important system, we think, on the path to the development of the and diffusion of this technology in Australia. Okay, so to the hydrogen microgrid itself, as I said, the building's called the Sir Samuel Griffith Centre, and here's the hydrogen microgrid housed in this part of the building. It's separated because then that takes the risk associated with hydrogen, HAZOP and so on, away from the architectural features of the building itself. This decouples them. So the only connection between the building and the hydrogen microgrid building, the main building and the hydrogen microgrid building, is in fact electrical. We have our own installation of excellent instruments on the roof and the weather station. We have thousands of sensors in the building that record everything to do with the interaction of the building with its occupants and with the weather and with the grid as well. It is grid connected because it has to work no matter what, but it's designed to operate off grid and to power itself from within its own footprint. The occupancy corresponds to a larger number of people than plenty of outback towns in Australia. So this is a kind of a paradigm for what can be done off-grid, or perhaps at the end of a long single wire earth return supply line, where you really need high reliability of electricity supply. And in certain situations, that's going to involve season to season storage, and that's where hydrogen comes into its own. This is a demonstrator building. It's not meant to be the prototype of any kind of commercial development. It's meant to demonstrate, to show people what the technology looks like, to prove that it works, and there is a kind of a political purpose that you can sense in a lot of that. It has research purposes as well because of the enormous amount of data that is collected from the building. So we do research using those data for modeling studies and so on. We have a 160 kilowatt standard industrial electrolyzer, which is housed in the other part of the building in here. Everything in the other part is electrical. Most of the non-electrical things are in here. Everything in here, the hydrogen storage room, is EX rated. We have a 60 kilowatt fuel cell, PEM fuel cell, which approximately matches the standing load of the building, the base load of the building. And we have something remarkable here, which is the world's biggest metal hydride hydrogen storage that's in civil hands, that is outside the military. Those in German U-214 submarines are bigger. The thing about this storage is that it's low pressure, it's very safe, it releases hydrogen very slowly. And this storage you're looking at here, and no attempt has been made to make it compact. It could be much more compact than it is. Fully commercial in its production, not off the shelf, but bespoke, but you can buy it commercially. And it's a simple system to use in many respects. And as I say, only 10 bar. 10 atmospheres maximum pressure. So this corresponds to about 250 ordinary laboratory G-size gas cylinders at about 180 atmospheres pressure. So what did we learn from all of this? And what I would say might surprise you in that it's not really about the technology. I could talk for hours about that, and we learned a lot, of course, but really the most important learnings that came from this are to do with how to do the project. And I think this is very relevant to the context of today's discussion. So this was done as a design and construct project. Money and risk were handed to a mainstream civil contractor. The contractor employed expert subcontractors to do the electrical works and design the microgrid itself. And this was a terrible way to go about the project, because unfamiliar technologies were involved. There were no explicit standards to deal with hydrogen. And so it was a very fraught process. And collaboration, as obvious as this may seem, between the stakeholders, definitely including some experts, whether international or in Australia, and there were some at the time, would have been, and eventually was, much more successful. So these 2 points are really about a kind of communication. You have to involve the right people, and you have to talk about the project, and you have to put all the problems on the table and figure them out. And that may seem obvious, but it didn't actually work that way in the commercial environment in which the project was conducted. One of the other things that's really important to get right is the size of everything in the system. You have to make all of this sing and dance together, particularly if you're off-grid. Every percentage point of efficiency matters, and the sizing of components so that they all work together properly is extremely important. The only way to do that is to model the thing. and simulate it at the design stage. So you design the system using the simulation. That's an enormously important task, and it's a complex one. There was a model done by the contractors, and when we reverse engineered it years later, we found it wasn't too bad, but many of the estimates initially were wrong. And after 7 years of work, the building still hasn't quite got down to the design load value. There are many components, HVAC components in particular, that needed to be brought under proper control so you could be turned on and off and have variable speed pumps instead of fixed speed pumps and things like that. This modelling and simulation are very cheap compared to building it and getting it wrong. We can speak from bitter experience in that respect. And this is also obvious. To integrate such a complex system, you can't just buy a bunch of components, check the communication protocols and the pipe sizes and the wire sizes, bolt them all together, turn it on and stand back and hope it will work. It just doesn't work like that. There's a lot of work done to integrate everything and make it work, and that has actually gone on for quite a few years to make the building work. It does now work. And so you should really build a simulation and use that to optimize the design of the system. By optimize, it really means set the sizes of the components so you also minimize the cost. You don't buy things that are bigger than you need, but you don't buy things that are smaller than you need, because then some of the other components will be too big. I realize I've forgotten to talk about one small point, and I'm going to go back to the previous slide and leave you with that. You will notice that the 1 megawatt hour lithium-ion battery bank has been crossed out. Lithium-ion batteries are dangerous, and this one caught fire in January and it was destroyed effectively, and it's been removed. So I'll just go back, I guess, to the learnings, and that was one of the learnings among the technical suite of learnings, and leave you with this. Thanks very much for watching.
Wow, thank you very much, Evan, for a great summary, some really great points there. And look, you really, I think, right through your presentation, you really talked about the thing that excites me a lot about the growth of the hydrogen energy sector, is that it's an integration and it's a collaborative opportunity like very few other growths of sectors. If people are coming at hydrogen energy from a linear perspective, they're unlikely to see what all the fuss is about, but it's the integration of technologies and peoples and business models, and as you say, not just an assembly operation, but something which is much more deeper than that. So look, thank you very, very much for that. I might just quickly run through the panel and just see if anyone's got any opening thoughts after Evan's great presentation. Perhaps Emma, have you got some initial thoughts? We're starting to get some Q&As in, which is great, or we're getting the Qs in. I think the A's are our responsibility.
Absolutely. I almost accidentally left the meeting, so I'm glad that didn't happen. That would have been a disaster on my first panel. So, okay, 2 thumbs up for me there. But I think there's 3 things that I really took away from Evan's presentation that was a fantastic opener for this panel discussion today. The first was the focus on safety. Safety is going to be incredibly critical for community acceptance of the hydrogen industry, and the more that we can do to talk about safety and the fundamental elements of that for the hydrogen industry, the better. And that comes with, and you spoke to that, Evan, about struggling with codes and standards for your project, and I think it'll be really important to have well-developed codes and standards. So the engineering design and the process safety standards for our hydrogen industry will meet community expectations. The second thing was just around what opportunity we have in the hydrogen industry, what opportunities there exist in the microgrids, and that's super exciting. And I think when we think about customer use cases, there's just more than we can possibly imagine at the moment. So there's real opportunity for us. And the third thing, as a project manager, the learnings from that project were fantastic, and the how we assign risk and value as we come together with different partners to deliver on these projects in the industry will be we'll absolutely rely on collaboration and innovation and potentially ways of working we haven't thought of before.
Great. Thanks very much, Emma. 3 really great insights there. Peter, particularly love to hear your thoughts.
Yeah, so thank you. Lovely to hear the presentation. And I think one of the things that comes away for me from the point of view of the social side and adoption of new technologies, which, you know, as we know, in some ways it is new, but it's not new because hydrogen has been around. But I think the thing about pilot projects or existing projects really help to build that confidence and to provide, you know, to the broader society and build some trust in the process. Because what happens is they look to these, the more broader public, to say, well, you know, what's happened there if it's actually already in existence. And when we did some early work with focus groups, both in Victoria, South Australia and Queensland, one of the things that was really comforting when we started talking about hydrogen as mobility and transport is that they could look and see refueling stations exist already in different countries, and countries that they trust and sort of think have good regulatory systems. So I think we can't underestimate, as all of these ideas for projects are emerging, how important that is for the long-term adoption. And then I think you pointed to another point, Evan, around, you know, this idea of what could have been learned if only that had the experts. And so I think what it also points to is this idea of interdisciplinarity and having the communications, the engagement, the technical people working to think about what is required and to be able to engage with those broad sections so that everyone's working collaboratively, both internal and external to the project, I think. And I'm starting to see that even when we think about safety, what emergency service and responders are doing and their information needs, because obviously that's going to be critical as these start to play out. And there's a bit of a chicken and the egg, but all of this I think is really important.
Yeah, great. And really good point there around, you know, let's learn from the international experience in looking at some of the things that we're doing and looking to do in Australia. Andrew, any sort of opening thoughts?
No, I think it's been pretty well covered. I'm just very pleased that Evan was available today. He's been very generous to us in terms of access to the facility and hosting delegations, etc. And I think it, you know, the capacity to go and see a hydrogen in operation integrated into a building is an invaluable opportunity that we have in Brisbane.
Yeah, and I think that opportunity to really have that practical, where people can, you know, they can actually see it working, actually helps the social acceptance, but also the sense that this isn't just some futuristic thing, but it's the here and now as well. So that's great. Evan, before we're going to go to our first poll in a minute, and then get into the audience question and answers. But Evan, you got any thoughts based on Emma, Peter, and Andrew's thoughts on your thoughts?
Yes, a couple of things. Just to add to something Emma mentioned about regulations and so on. Just yesterday I was part of a discussion with Standards Australia on the emerging hydrogen-related standards. And there are some of them already adopted and published, and there will be others developed over the next year or so in a kind of beta version. So yes, that's happening quite quickly. And that's really, really encouraging, because previously there was just a vacuum. The social acceptance stuff here is so very important. In the Blue Economy CRC, we have the best part of an entire program, in the biggest CRC that's ever been in Australian history, devoted to such matters, the business aspects, the social acceptance aspects, including links to Indigenous communities, the risk, some environmental aspects, of course, and so on, as well as the actual hydrogen business itself. So yeah, these are all, people tend to view these things as you said, in a somewhat linear or serial fashion, and of course you can't. You've got to look at the whole picture. And when we do modelling of entire systems, we actually deal with 4 things. We deal with the technical performance, necessarily. We deal with the dollar cost, I call it, necessarily. We deal with the environmental footprint, or the environmental cost, or the avoidance of environmental cost. And we also deal with other factors which can be any sort of quantified social factor that you can give us a number for, and so you can optimize the system to take all of those things into account according to who you are and what your priorities are. So we advocate that as a way to approach complex projects like this and actually take into account the fact that people maybe hate wind turbines for whatever reason, or they're afraid of hydrogen, or there are many things. And I was also, this is the final thing I'll say before shutting up, I'll also say that thousands of students walk past the Sir Samuel Griffith Centre every day, at least when COVID-19 is not around, completely unaware of what goes on inside it. It's just a building containing some strange-looking stuff.
Right, great. Thank you very much, Evan. And look, thanks everyone for completing that first poll. It looks like about 47%, just about half of the audience are really interested in business and investment opportunities from hydrogen, which is great because that's going to really help the adoption for actually be able to be using it and investing and using it in their business. And hopefully we'll see some scale benefits which will actually create some momentum as well. So look, we might move to the Q&A part now, getting some questions coming in, which is great. I might tend to open these up to the panel, knowing there's a mixture of skills and experiences, but the first two questions, and for the audience as well, if you'd like to upvote, so if you see that there's a question that someone's already got listed, but you would like to you'd like to hear the answer to that, then please hit the thumbs up to move it up to the top of the list. And this might be a question for Evan, but the first two questions are around electrolysis, and one was around does seawater need to be desalinated before electrolysis? And the other one was around, does groundwater need to be demineralized? Anyone else can jump in, but perhaps Evan, have you got some thoughts on that one?
Happy to answer those, Paul. So the first one, does seawater need to be desalinated? In principle, possibly not. I think there are some research programs going on dealing with seawater as seawater. After all, you do have a conducting electrolyte in at least alkaline electrolyzers. But generally speaking, if you want to run, say, a PEM electrolyzer, which is where all the big developments are, you can order hundreds of megawatts of PEM electrolyzers now. Well, you might not see them for a while. You need to totally demineralize and purify the water to a quite high degree. So if you take town water, for instance, which means different things in different places, I know, you need to run that through a reverse osmosis plant, typically, to be able to use it in the electrolyzer. Hydrogen from the other one was about groundwater. They're moving around. Yes, same answer. So having said that, there are electrolyzer companies who are looking to build their business by linking big electrolyzers to, say, wastewater plants where there's grey water available. So the cleanup then becomes important, but then you are able to use something which was otherwise going to be waste as the resource that goes into your system. So it's not exactly straightforward, but yes, any kind of water ultimately can be used once you've cleaned it up appropriately.
Yeah, that's great, Evan. And obviously things like oxygen and the minerals can be value streams in their own right coming out of those processes. It's not just about the hydrogen either.
The oxygen's an interesting one in the blue economy context because aquaculture needs oxygen. There are certain times of the year when they use a lot of oxygen for remediation of various conditions and treating water in big fish farms at sea. So yes, oxygen as a co-product of hydrogen there is important, and it's obviously important in other industries as well.
Yeah, fantastic. Does any of the other panelists like to talk to that issue? No? No? Okay, we might move on. Okay, so next question's around the readiness of the Australian transportation market and global market to adopt hydrogen fuel for transport at scale. What are the key hurdles to overcome? Is there someone that wants to leap in on that? Otherwise, I'll name someone. I'm feeling like a school teacher now.
I'll have a go at anything.
Emma or Andrew or Peter?
Peter, did you want to have a go first, or?
I can talk. I mean, I'm not a technical expert, but I guess from having participated in some of the hydrogen discussions and so forth, I think there is where they see hydrogen for transport being the long vehicle, sort of long haul, I think is a real opportunity. We do see hydrogen also around You know, it's already in use in different countries, as we know. The fact that we have a fairly established electricity thing means there's always this discussion around battery electric vehicles versus hydrogen fuel cells, and then the weighing off between costs and benefits and those. Do we have access to the hydrogen and so forth? We're pretty excited. We've got a project that, you know, is exploring at the opportunity of hydrogen into campus buses from Gatton through, and that's also looking at the use of wastewater and so forth. It's only early stage, but I think there's a bit of a tiered approach to where this will come on, and I'm sure Evan, you might have some other views on this as well, or Andrew. But so I think in the first instance, this idea of that it could be a really good game changer for long haul transport as a way of decarbonising that, especially when you've got broad, large open spaces. We're seeing it also perhaps more localised at mine sites, and fleet vehicles is another way where it could actually really add value to the whole decarbonisation of the transport. That's just my initial response, but I'm happy for someone else to jump in and add to that.
Yeah, I'm happy to have a go, Emma. So CSIRO in their work have identified that heavy vehicle transport as one of the likely early cost competitive uses of renewable hydrogen. And I guess that we're seeing that same sort of priority reflected in the investment inquiries that we are fielding in certainly the back to base heavy vehicle space, so garbage trucks, buses, and also back to base heavy trucks. We're certainly seeing a lot of investment interest in that space, and I think that reflects, where it's likely to be a quite early cost competitive use of hydrogen.
Yeah, I'd agree with the views put forward by Peter and Andrew. I don't have anything else to add on transportation.
Yeah.
If the query is more around the transportation of hydrogen as opposed to the use of hydrogen for transport, it's not entirely clear. That's a different question, and there's obviously challenges in the transportation of hydrogen. It's obviously transported nowadays, not tube trailers, etc. But in terms of moving to export, there are certainly some challenges in working out the appropriate vector and making that cost competitive.
Yeah, sure. And I think the question is probably more about hydrogen fuel for transport. And Peter, I know that you've just joined the HySol Technology Hub Advisory Board with Deakin University down in Warrnambool, where they're looking at that sort of work. I know that Hyzon's just signed a deal with FMG. There's the H2Oz bus consortium. So I think there's quite a bit happening in and as you say, at the sort of long haul, mining trucks, kind of off road, whether it's rail or whether it's buses and all those types of things, seems to be moving. I think watch this space over the next couple of years. Next question's around hydrogen from waste plastic projects are being implemented overseas. What about in Australia? Has anyone been in the hydrogen from waste plastic process? I mean, I know that our circular economy, our waste industry in Australia is getting a lot of attention at the moment, particularly with the inability to move it offshore, move the waste offshore, which is hopefully going to spurn a new industry in Australia. But has anyone done much in the hydrogen from waste plastic?
I haven't, but I have recently been party to some discussions about projects that might be developed in Australia. So there is certainly an interest in Australia.
Yes, I know that there's a project up in the northwest England area where they're already investing, I think, £20 million in a hydrogen from waste plastic project. And I know there's some players in Australia. Viridius Energy in Brisbane has some licensed technology around hydrogen from waste plastic, and there's others as well. So again, watch this space. But it does go to the sense that there's a number of applications for hydrogen and a number of ways of producing it from waste resources and from water. So okay, so just another probably technical question: how many kilowatt hours electricity per megajoule of hydrogen out of an electrolyzer?
I can answer that one if you like. So a kilowatt hour is 3.6 megajoules. and the efficiency of the electrolyzer is about 60%. So that's about 2 megajoules of hydrogen thermal energy out of 1 kilowatt hour of electricity. To put it in another way, our 160 kilowatt electrolyzer produces 2.3 kilograms of hydrogen per hour.
Right, okay, great. Thanks, Evan. Emma, I might ask you a question about skills. What are the skills gaps that need to be filled to create the hydrogen economy? Is that something you're looking at hydrogen, at Origin Energy?
Yeah, absolutely. And if I think about kind of the project life cycle, I think there's 3 types of skill sets we've got to think about. We've got to think about and Evan talked about it before, the engineering skill sets that we need to design the facilities. We need construction skills, we need like specialist welding skills, and we'll need skill sets for operating the facilities that we're talking about. So, I mean, we have a hydrogen industry in Australia for 50 years, but we will need to build additional specialist skill sets and technical skills in order to support that into the future. So I think that's pretty exciting.
Great, thanks Emma. Anyone else want to talk about skills in hydrogen? Peter?
Mine's a more generic sort of conversational observation where I'll be, talking to the people down at Warrnambool and people in Gladstone, and I know some of these regional universities are seeing it as a potential real opportunity for their campuses to upskill in those places, which I think is quite exciting. If you could think they're being situated around the different states as hydrogen projects move, if there was this sort of core competency that comes through those, I think it's sort of quite an exciting thing to think about, sort of from the regionalisation aspects. It's not for all of the skills, but I think that's something that's sort of worth considering as moving forward, potentially.
Yeah, and I think one of the things that I'm seeing as well is that in a lot of places, there's a really great transfer of skills into the hydrogen energy economy. So there's people that have worked in industrial chemicals, there's people that have worked in maybe the coal seam gas space and the LNG space that have understandings of high pressure gases, and they have understandings of liquefaction, and they have understanding of large manufacturing processes and gas pipelines and the like, that I think, and even refueling, that people, that in some ways it's kind of collecting existing competencies and lining them up in the hydrogen economy. Andrew, any thoughts on skills? I think the Queensland government's investing in an apprenticeship centre around renewable energy and hydrogen. Is that correct?
Yes, so down at Beamley, there's been a substantial investment made into a facility that's being developed down there. So certainly we're very mindful of the opportunity in the skill space and that capacity to leverage off the existing capability, particularly in the LNG space.
Okay, great, thanks. Next question. Having involvement in green technology, what other areas have been researched that can work in conjunction with other technologies? What is the risk assessment that have been conducted as into environment? Not quite sure of that question. Does anyone want to have a go at that question?
I think at a high level, it is really important that we understand what the sensitive receptors will be when we contemplate where we'll be putting our hydrogen infrastructure, and in those local areas, understand what those sensitive receptors are and how we can manage risks associated with them. So so that approach will be really important as we further develop hydrogen projects across Australia.
Thanks, Emma. Question around the role of blue hydrogen in transitioning to green hydrogen. Will industry hubs for both CCUS and hydrogen be integrated? And there's perhaps an associated question around the pros and cons of handling and using methane or ammonia made from hydrogen. Ammonia is obviously already made from hydrogen through the Haber-Bosch process using methane. So there's probably a question there around the integration with CCUS and with blue hydrogen, the creation of blue hydrogen. Emma, Peter, Andrew, Evan, who'd like to have a go at that one?
Who's going to start? It's hard. You go.
You go, Peter.
Okay, I'm talking again from the public acceptance social side, not the hardcore technology. That's far better addressed by Emma and Andrew, I'm sure. But there's been a whole lot of work around CCS and CCSU, I suppose, or US as we see. From the perception point of view, it depends on where it's situated. How, you know, is it a transition? All of these sorts of things play into how the public view that, and the response to it, I guess, is one of the things that I would add in that sort of as we move forward. I guess just sort of responding from that.
And I think I'd just throw a customer lens onto this question of you know, whatever colour we want to talk about. It's really going to be customer driven, and so I think you know, if there are synergies to be had in integrating those different types of hydrogen production, you know, ways of producing it, then that's, you know, so be it. But it's going to be customer driven. It's going to be determined by really what the customer wants. And the conversations we have with customers, they tell us that they don't really care about the colour. What they care about is whether the hydrogen's made from renewable energy or not, and what the carbon footprint is. So I think if you take a customer mindset to that, I think that's really the most important kind of way of thinking about that problem.
Yeah, and I think that's probably why one of the early actions out of the National Hydrogen Strategy was looking at the issue of certification, because it will be very important for people. They won't be able to tell if they get liquid hydrogen or liquid ammonia presented to them, or MCH or something else, what the carbon footprint is of it is. And so and that will be really important, and that will probably have an impact on pricing, so in a considerable way. So Andrew, I think you want to have a say around this?
Yeah, I think I can reiterate what Emma's just said in terms of the customer-driven outcome. I think in our sort of discussions with international partners, potential partners, there seems to be a general recognition that there may well be a transitional period, but the ultimate objective would seem to be that they want a truly renewable or low carbon emission product, and that you know, there's a very complex question or that goes in terms of, okay, what's the ultimate process? Could you have conversion steps and energy steps that go in terms of the translation into different forms of hydrogen? And it'll also depend a lot on what the customer wants to use that hydrogen for, the difference between putting hydrogen or ammonia into a power generation process as opposed to using it in transport. So we're certainly, in terms of our input into the hydrogen certification process, I guess we're very much driven by what the customer ultimately will want to see in terms of being able to differentiate where the hydrogen in inverted commas has come from. Okay,
great. Thanks, Andrew. Look, Evan, a few questions around perhaps a couple of simple questions, and then perhaps one requiring a longer response. But is the Samuel Griffith Centre hydrogen system open for viewing by the public now or post COVID? Obviously, people can visit the centre, but whether they can actually see the what's under the skin, if that makes sense.
It's possible to walk up to the building and look through the windows, and if they've been cleaned, you might even see what's inside. Another thing that the public is welcome to do, although under the present circumstances I'm not sure if it's open, is to visit the so-called red zone, which is a public demonstration, fully interactive with huge screens and quite a lot of information about the energy system, which is right next door in the building itself on the ground floor. So normally that would be open to public access. As far as getting inside and seeing the equipment itself, that's a by appointment thing. I don't have a key, I'm only a professor. So it's a matter of arranging that and arranging access and so on, and swearing to turn off your mobile phone and so on. So, but you know, interested potential industry partners and potential colleagues are very welcome. We do have some tour. We used to have some tour groups before the present circumstances took over, taken through. So do you want me to continue down the list, Paul?
Well, yeah, there's one there around standardized. Is there a standardized metal hydride chemistry for hydrogen storage? Perhaps you could answer that.
Oh, okay. Yes, I can't see the same questions you can. Oh, that's probably because I'm in the wrong place.
That's okay.
No, there isn't. The thing about metal hydride, not to give you a lecture, the thing about metal hydride storage is it's a chemical reaction, and the pressure and temperature at which metals absorb hydrogen depends hugely on the chemical composition of the metal. So you can tune them to absorb hydrogen in a huge range of temperatures and pressures. If you take pairs of materials, you can make hydrogen compressors, you can make heat pumps, you can make air conditioning, refrigerators. We use metal hydrides in the laboratory to generate pressures up to 1,000 atmospheres, or you can generate mild vacuum as well. So it's enormously flexible.
Great. And I'm aware of the Lavo technology that is probably going to launch later in the year for residential solar storage using hydrogen in metal hydride as well, using some technology, I think, licensed some technology out of the University of New South Wales. So that's an interesting development to look out for, I think, in the next few months. Emma, you?
I was just going to make a comment to just recognise that storage is going to be one of the biggest technological problems that we have to solve. And while metal hydrides are, an option on the small scale, that technology is a horizon way out in front of us in terms of what we would contemplate for today. So just to just add a bit of context that I think metal hydrides have some great opportunity into the future, but I can't imagine our first commercial scale hydrogen projects are going to be looking at metal hydrides.
Yes, I should say something about that, and I apologise for not making it clear that the applicable scale is small, up to about 1 tonne of hydrogen. So if you wanted to take somewhere, since we have someone from Origin here, and Queensland, Dormagee, if you want to store a ton of hydrogen in a community like that, you could contemplate metal hydrides for all sorts of reasons, but there is no single solution. And once you get above that scale, of course, you look at other means. Compressed gas has all sorts of applications in high pressure containers, liquid hydrogen, and so on. The horses for courses is the watch phrase.
Yeah, thanks. Look, and we're probably almost getting to the end of our questions, and unfortunately, well, not the end of the questions, at the end of our time together. But there's one question which is getting a lot of upvoting, which was, if I was manufacturing hydrogen right now in Australia, who would buy the hydrogen? Is there a market here now? What would the hydrogen be displacing? Could you estimate a cost that hydrogen would need to be competitive right now? Which is probably a difficult question because there's lots of different applications, and hydrogen is being manufactured right now in Australia for industrial chemicals, whether explosives or fertilizers, et cetera, and in the ammonia process. But in terms of hydrogen energy, I suspect, what would the market look like now, and what would it be displacing? And then what do the costs look like? Emma?
Look, I think I would say that we have conversations with domestic customers that say there is a market right now if we are able to, connect the supply chain and provide them with the product that they're looking for. I think, to Paul, your point, there's kind of 3 buckets of usage. So, fuel for transport and power, heat for industry and buildings, and feedstock for chemicals and products. So, there's infinite array of uses for hydrogen. We just need to be able to connect the supply chain to actually distribute the production of hydrogen to the customers that need it.
Okay, fantastic. Peter, Andrew?
I'm happy to go. I think, so just to put a bit of context, obviously the open commercial market for hydrogen, it's fair to say, with most of the hydrogen being produced and consumed in large volumes, co-located with, refineries or ammonium nitrate plants, etc. Most of the investment inquiries that we are seeing are coming in, and they're both the presumed producer and the customer in effect. So they will be producing hydrogen not for an open sale, but to actually utilise it within their own vehicles or other activities.
Right, great. Thanks, Andrew. Peter?
Well, I guess it's just, from the export, the international holy grail thing is getting signed, purchasing agreements to really sort of deliver. But at the same time, the whole issue of scale is still a challenge. So I guess that's sort of the longer term horizon where we know, there's agreements with Germany. We've got Japan and Korea, holding up their hand, but it's the actual signing on the dotted line, I think, which is from an international still a way off at this stage, but I think the whole world is, we've got mission innovation looking at it around the world. So others might like to comment to that international scale. You've probably got some ideas too, Paul.
Quite possibly. They may be misguided ideas, Peter, but I probably do have some ideas. Evan, you obviously come in touch with a lot of people. You're not quite a tour guide there at the Sir Samuel Griffith Centre, but you must have a lot of inquiries. And how do you see those early markets, I guess, for adoption of hydrogen playing out?
Yes, tour guide is my second career. Paul, there's a lot of chicken and egg in this. The classic is the rollout of hydrogen vehicles, be they heavy vehicles or light-duty vehicles. The vehicle manufacturers point at the absence of infrastructure, and people who might finance infrastructure point at the difficulty of getting vehicles. That's that side of it. But it's typical in a way of, I think, the entire scene, in that it's as if you need to elevate two parts of the same problem at the same time rather than trying to solve them one at a time, because that's not working. But in terms of going to an entirely practical context, in terms of our hydrogen microgrid we'll be building for the Blue Economy CRC, which is going to be physically located somewhere in Tasmania, we will need an offtake agreement. For the hydrogen initially, we don't think we'll have any trouble getting an offtake agreement. There are enough projects around the ridges now that one of them is going to come good and want the hydrogen. And as usual with things like this, hopefully some small start like that will then provide a basis for other larger scale projects to get up and go. The domestic context is really important. I mean, this is something that was made clear by Minister Dick in Queensland at the launching of the Queensland Hydrogen Strategy, I think it was last year, that yes, export's really, really important, but let's not forget the domestic context. We want to start small, go carefully, and build this so we take only, I'm paraphrasing, not deliberately putting words in the minister's mouth, but go forward in small steps, don't go backwards. And I sort of think that's what's happening. There are so many discussions around projects that aren't fanciful, where there really is, say, venture capital involved, where there really are technical experts involved, where there really is the proper engineering expertise on board, and so on. So I think all the elements are there, and you can imagine that before long, a few initially smallish projects will get up and it will grow from there. But that's not unusual, but I imagine that's the way it's going to happen.
Yeah, fantastic, Evan. And look, it reminds me that, in Australia, 34% of our carbon emissions are in the electricity sector, and therefore 66% are outside the electricity sector, and in things like transport, in the industrial sector, the agricultural sector. And in some ways, they're the areas where we're perhaps likely to see things like hydrogen, and particularly zero-emission hydrogen, whether it's through blue with storage or utilisation, or whether it's directly through green hydrogen, probably getting some early areas where perhaps electrification doesn't quite get to. So it's good to have a number of these tools at our disposal, I guess, and I think as the International Energy Agency's Energy Technology Perspectives of just earlier this week came out and looked at 800 different energy technologies and to 2050, I think we're going to be in for a much more integrated and complex energy mix and energy system into the future than perhaps we've seen in the past. I've noted that we're just over 1:30, so apologies for that. We haven't got to all the questions, but I can assure you that we will take note of those questions, and that answers will be collated and sent on. But look, really enjoyed the discussion. I hope the audience have enjoyed the discussion, and the rest of the panelists. To Evan, to Emma, to Peter, to Andrew, thank you very much. Really enjoyed the panel session, learnt a lot, and I will now hand back to Tiffany. Thank you.
Thanks, Paul, and thank you to all of the panel. That was a fantastic session. And those questions, we will send those out to our panelists, and we'll get some of those answered and include them in the follow-up communication that we'll send out to everyone who registered. Just to let you all know that we will be having a dedicated stream to hydrogen in our virtual conference coming up in November, and that'll include innovation and case studies, so please watch this space. So thank you to Paul, Emma, Peter and Andrew, and especially to Professor Evan Gray for sharing your insights and expertise today. Really appreciate that. So thank you once again to everyone for watching Cleantech Conversations, and we hope to see you in November.
Thanks everyone, thanks to the audience.
Thank you very much.
Thank you everyone.